you everybody who is watching this video? My name is Olenjolaim. Simply call me Olenjolai, from beautiful country called Tanzania, eastern of the African continent. I would like to welcome you, whether you are international viewer or national viewer. You're warmly welcome, and I would like to welcome you into our online diploma under Online Diploma Polytechnic Institute of Tanzania in square bracket Olenjolaim. And simultaneously, I would like to take this opportunity to welcome you into our YouTube channel as called the Online Diploma Polyinstitute of Tanzania in square bracket Olenjolaim. But this, for the diploma, we don't have this letter of M, so just have the name Olenjolai itself without M. Well, so it's a fantastic moment to have you in these programs today. I have a very good news, as I've written there on the blackboard, and I'm well prepared by God in order to deliver that good news to you in your minds and write something remarkable and even rememberable for the rest of your life. So it means that you have to be, write some piece of information that you remember for the rest of your life. So before we go inside the lecture or the session called the lecture 16, I would like to spend a few minutes to remind you about the vision we have in Online Diploma Polytechnic Institute of Tanzania. Well, this is the vision that God has revealed to me for the long times, and also insisted me to reveal and repeat it in the mind of our students, because we are doing something differently and we teach our students to think differently. So God has written this message in my heart, or these visions in my heart, that I have a responsibility to train, to teach, to incubate, to mentor, to lead some group of students who are ready to take the classroom instruction, right, from basic engineering mathematics or basic scientific mathematics, combining with the knowledge that they used to get, or they get their formal education in the core courses or modules. For example, that highway is one of the core modules in civil engineering, right? And also another one's introductions to the computer programming. Introduction to the computer programming is the one of the core course of the computer science or computer engineering. So these students, or this group of students, will be ready to take the classroom instructions in those areas of interest, mathematics and the core subjects, or engineering, or mathematics and science, right? Combining with the knowledge from the Word of God in the Bible in order to solve real-life problems. According to the curriculums and according to the educational system worldwide, and including the one that we have in Tanzania, it means that ordinary diploma, it's a level preparing fresh mind for the basic technicians. So the basic technicians have to solve real-life problems, not only have to own the certificates. That's not enough. Certificate just to introduce them, and even just to confirm that they are formal educated. So remember that vision. We have a responsibility to teach some group of students who are ready to take the classroom instructions in mathematics and science, or mathematics and engineering, combined with the knowledge of Word of God from the Bible, not from every book, from the Bible, because the Bible is not for the Christians. The Bible is the idea of God, reveals the mankind on how we have to live in the physical world, under the guidance and the governance of the invisible world, right? So I don't want to explain in details, but just stay tuned, then we'll know the difference and the meanings of this sentence that I'm trying to make before you right now. So our main objective in Online Diploma Polytechnic Institute of Tanzania is not to train students to pass the year exams. Our main objective is to see the basic technicians who are still at college or institutions or university. They try to think every time, or they have to think that how they can apply the information they are gathering in the class to solve the real life from the year community. That is our main objective. And it's the issue of the mindset. It's not even the issue of the economical factors. Firstly, is the issue of the mindset. Because let me just share with you a little testimony. Myself, I'm a product of formal classroom instructions in engineering mathematics, also in engineering, especially in the area of electrical engineering, and my area of interest is electronics, telecommunications, computer engineering, biomedical, you see, and even electrical engineering itself. But specifically, it's electronics are the mother of all of those areas of interest. So I'm a product of the classroom instructions, but also I'm a product of the Word of God, right? So I'm a product of those two areas, or those two kinds of the unrelated areas according to the physical laws and principles that mankind has established in the world. So what am I going to teach you and how am I going to mentor you is what I used to live in myself. And I've seen so many advantages. That's why that I received this assignment to also induce the spirit, the same spirit and the same mindset to millions of the students in the present and future generation. So we have some of the departments in Online Diploma Polytechnic Institute of Tanzania. Currently, it is still on online institutions. We don't have a physical institutions, but we are still praying to God. God is faithful. Possibly one day, before we departure into the in this physical world, we might have it. So stay tuned and focus on that. So we have a module on the course called conics and differential question. And the good news that this module is taught for the in the first semester of the third year, right, for the ordinary diploma student. And also we say that so that the piece of information we're still in chapter 1, and this is lecture 6. It's titled as intersection of the cycles orthogonal. Said intersections of the two cycles orthogonal. Wow. So just say that that's the year of the study, first year and the second year. Yeah. So that is. So yeah. So in case also you feel from your heart that you want to offer God, not OLENJOLAI, because OLENJOLAI have nothing to give you. You want to offer God your free willing thanksgiving. So these programs, you're warmly welcome. And really we are happy to see that, and even that we'll be encouraged to see that even our students are participating in the running cost. We don't charge you any amount of money. We don't charge you even a single shillings of 2 shillings or a US dollar or a euro. So we are providing this content free of charge because the manufacturer or the founder of these programs in my heart, who is God himself, gave me the instructions to do it for an interval of a year, right? So in case you want to offer a free willing thanksgiving, so you've got to state yourself to offer, so this telephone number 0759745331. The confession name is OLENJOLAI TAYAI. But in case you want to do the bank transactions, yes, you have to check the descriptions below. You can see the bank account, the bank name, and the bank the bank name and the bank accounts and the bank and my name also, the owner of that bank account. So let us go now to the very important moment. So I would like to do the quick review. Up to this moment, in conics, right? In conics, I've already added or uploaded 6 video lectures of conics, all about cycles, right? So let me do the quick review of the recently lecture in order to link the lecture 5 and lecture 6. So in that lecture, basically, I taught you about internal intersection is just like the intersections of 40 of cycles, right? Intersection of the cycles, and we say that 2 cycles can intersect internally if we find that there is a relationship between the ear centers and radius, right? So this is the center for this large cycle, and this is the center for the small cycle. So let's say this is center 1, this is center 2, right? Then here it is R1, this is R2, but this R2 also is this side. So if you remember the condition, you say that R2 minus R1, this is equal to distance between 2 centers. That's the condition, right? And also we talked about external condition, external intersection. So intersection of 40 of 2 cycles also. So intersections of 2 cycles. So it's an intersection of the 2 cycles. You have cycle 1, and here we have cycle 2. So we have 2 cycles, cycle 1, and also here we have cycle 2. So then this is the center and this is the center, the distance between them. So this is center 1, center 2. Here you have radius 1, radius 2. You say the condition is if R1, R2 is equal to the distance between the two centers. So those are the two conditions. And then we left the homework for you, which was homework 5. And the questions was asking you that to state determines whether the two circles intersect internally or externally. And the answer now, the answer, for those who remember it, the answer is means that in the circles, okay? So the circles do neither intersecting internally nor externally. So that's the answer. Hopefully, I believe that you have got it. So let me teach you now the new concept, which might be even the lasting concept according to the curriculums of ordinary diploma. We have, say that the intersections of the two circles of orthogonal, right? So, what is, so the fundamental question, right? What is orthogonal cycles? What is, or what are orthogonal cycles? Or in other words, what the means of intersection of the two cycles of the cycles of orthogonal? Okay? So there's some definition. There are so many definitions of this terminology, but you say that the orthogonal cycles or orthogonal, say orthogonal cycles, right? We say that are the two cycles. These are the two cycles. In case you find that I'm teaching you quickly, you can revise this video several times until you understand what I'm teaching, which are intersecting. So we say that are the two cycles. So we say are the two cycles which intersect, ending, which intersecting together, or ending the ear tangents. The ear tangents line. You remember that I told you the condition for the straight lines to be a tangent to the cycle. The tangent lines at the point, they're passing at the point of intersection, at the point of orthogonal intersection, means passing, not at, passing the point of intersection, of orthogonal intersection, are perpendicular to each other. And these are the conditions which help us to determine whether two cycles are perpendicular to each other, perpendicular or orthogonal to each other. Okay, are the definitions of what orthogonal cycles. So remember that the vocabulary orthogonal in mathematics, this is equivalent to the word right angle, and also this is synonym in the word perpendicular. So that it says orthogonal cycles are the two cycles which intersect, and after intersecting, which intersect orthogonally, so they keep intersecting, and then the ear tangent lines passing through the point of intersections or the point of orthogonal intersections are perpendicular to each other. So because you want to say that derivation So let me teach you, because sometimes you find a question ask you that short. So the revision of the formula that determines orthogonal intersection. Orthogonal intersection of two cycles, right? So I will derive this formula quickly by following some steps. So the first step is saying that consider two cycles below which intersect orthogonal. So because we need enough space, let me draw it here quickly because I have so many issues to do with you today. Okay. So suppose that we have two cycles which intersect orthogonally, and the way that these two cycles are intersect at 2 points. Have 2 points of intersection. This is the first cycle, and hence you have the second cycle. Possible that maybe sketching the cycle and drawing, you have to draw. Then here we have the center, so here we have the center. So this is the point of intersection, let's say P, this is the point of intersection Q. Suppose that this is cycle 1, and this is cycle 2. So this is center 1, this is center 2, and this is center 1. So according to the definition, we say that orthogonal cycles are the cycles which intersect the two cycles which intersect, and their tangent lines passing through the point of orthogonal intersection are perpendicular to each other. So where this tangent line, this one, perpendicular to each other. So what do we say? That we say that we have a tangent line for the cycle 1. Let's say we have a tangent line here, which is a straight line, touching cycle 1 at only 1 point. So this is a tangent line for the cycle 1. And here we have y, m, x, let's say y1, and then x1 plus c1. Right? So this is tangent line 1. Then again we have another tangent line which intersecting or is passing also at point P, right? Point P, just like this. Okay, so this is another line, this is another tangent line. So this is y2 is equal to mx2 plus c2, right? So again here we have now a right angle triangle. So we have a right angle triangle, right? Right angle triangle. So this is tangent line 2. Okay. So what happens here, right? What happens here? So I think that it's better if we draw them. We may redraw it again because I've missed something there. Okay, I've missed something there. Okay, so we draw circle 1. And then here we have circle 2. So this is circle 2. So circle 1, circle 2. This is center, and this is center. This is point of intersection, P. This is Q. This is cycle 2. This is cycle 1. Okay. So then we say that here we have a tangent line to this cycle, the cycle 1, passing through the center. So this is C1. And also here we have another tangent line passing through the center of cycle 1. Okay, this is the tangent line. So this we call the tangent line 1, and this we call the tangent line 2, and this is the quotient is y1, line 2 or line 1, and this line 1, okay, line 1, and this is line 2. So y1 is equal to m, y2 is equal to m x2 plus c2, and hence this one also say that this is y1 is equal to m xc1 plus c1. This is the point of orthogonal intersection, because the tangent for the tangent 1 and tangent 2 here meet at orthogonal at right angles. So this is the orthogonal point. Again, here we have C2, and then here we can have a distance between the two centers. So remember that this is 20p. So you know the centers of the cycle. We know them, center 1, center 2. And the coordinates here are F1, G1, and the coordinates here are F2, G2. And hence you have this point of 40 of intersections, which is P, and which is perpendicular. So then we say that this is figure 5.1, figure 6.1. Say that orthogonal intersection. Just that you find a duality quickly, you have to review intersections of 40 of two cycles. So you have to review this video several times as you can. Okay. Hopefully you have understood. In case you have any question, you may ask it in the comment section. So now that the first step, we have already sketched our orthogonal cycles. Now we have to go for the second step. In the second step, you have to consider Pythagoras theorem, if I'm not mistaken, of the right angle triangle. So the second step, the second step, we say that consider right angle triangle, which is this one. And this right angle triangle, we call it C1, P, C2. Right? So you can redraw the way that you want. Let us redraw in simple way, like this. This is perpendicular point. So it means that this is tangent 1. Let's say this is tangent 1. And this is tangent 2. And this is the right angle. So this is point P. And this is point C1, which is coordinates are what? We say F1, G1. And this is coordinates C2. And this C2 is coordinates are F2, G2. Hence you have point P. Okay? You have point P. So So here point P, here's point P, the corners of point P, are they there? Again, we say that, remember that the distance from this center to this, to the circumference here, is equal to R2, radius 2. And the distance from this center 1 to P, this is called the R1. So it means that here adjacent, PC1 we have R1, PC2 we have R2. Right? Then we can have our angle right now. Have our angle. Just that we need an angle, but it's not necessary actually. So we have R1, R2. So what should we find? We should find the distance between these two centers. I mean that is C2 because it's a hypotenuse. And it's adjacent this dot to support that here we have our angle, but we are not interested in that one. Set this tape. Recall Pythagoras, which you told you in Form 2. No, in Form 2 or Form 1. I don't remember exactly Form 1 or Form 2. Pythagoras theorem. Pythagoras theorem. So if you recall Pythagoras theorem, we know that if you have the side labeled as a square plus b square is equal to c square. So for our case now, that is a. A possibly that is p to c1, which is r2 square, plus p to c1, which is r1 square. This is equal to what? This is equal to the distance from what? C2 to C1 square, which is the hypotenuse, distance between these points. Okay, so still enjoying the beauty of basic engineering and scientific mathematics for ordinary diploma. Well, so if that's the case now, we know this radius, so we say that C1, distance between center 1 to center 2, I have to use distance formula. So suppose that this is equation 1, right? Equation 1. Then we go for this first step of our derivation. So we say that we call distance formula. Call distance formula in coordinate geometry. Distance formula. Okay, call distance formula. So the distance we are looking between C1 to C2. This will be equal to the square of the difference of the points. So it means that for this case, it is F2 minus F1 square plus what is G2 minus G1 square. That is. But again, if you examine the question, so yes, so this we call it. So this distance, which is distance between C1 to C2, possibly even here we can say that here you have a distance, so it's equal to distance. And this I put them as the subscript of D1, C1 to C2, like this one square. So you say that even here, this distance of this stuff, this is equal to the square root of what? F2 minus F1 square plus G2 minus G1 square. This will be second equation. So we go for the fifth step. The fifth step, we say that substitute equation 2 into equation 1. Equation 1. So substitute equation 2 into equation 1. This is R1 square plus R2 square is equal to square root. Right? So it's equal to open bracket, square root of what? F2 minus F1 square plus what? G2 minus G1 square. And then we do square. So if we do that, we say this is R1 square plus R2 square is equal to. So if you square both sides, you have F2 minus F1 square plus what? G2 minus G1 square. Okay, so we say that this is equation 3. Good, beautiful. This is the beauty of basic engineering and scientific mathematics. So then we go for the 60th step on our derivations. What are we deriving? We are deriving the formula used to determine the orthogonal intersection between two cycles. So the 60th step, we say that in, let us expand equation 3. So I'm going slowly, and I want to teach you step to step so that you can comprehend materials and keep them in your mind for the rest of your life. Well, so if you expand now, here on the left hand side, we still have under 1 square, radius 1 square on the first cycle, radius of the second cycle square. Then if you expand now, we have f2 square plus f1 square minus 42 f1 f2, right? 2 f1 f2, then plus g1 square minus 2 g1 g2 plus g2. Similarly, even for what I've written there. Okay? So that is. So you have to see stuff. So you say that this is R1 square plus R2 square is equal to what? Is equal to, you have F2, that one's okay. So we have F2 square plus, or let's say that minus 2 F1 and then F2. But I think that let me collect the like terms, the square terms, so that I can simplify them. So then, we say that this one should be F2 square plus F1 square, as we say, minus 2 F1 F2. Then plus what? Plus G1 square plus G2 square minus 2 G1 G2. Right? So this is what? Equation 4. So again, we have to think on how we can simplify to get meaningful piece of information. So we have to go for the 7th step. The 7th step, we have to recall. The 7th step. The 7th step, you have to recall previous formula that we used or we deduced when we've been deriving the standard translated, the standard equation, deriving the standard equation of the cycle, or the standard equation of the translated cycle. So 7th step, we say that we have to recall that radius of the cycle, this is equal to f square plus g square, if I'm not mistaken, minus c. Is it? Let me check. Yes, f square minus what? Minus c. Right? So that's the case. So r square is equal to that one. So here we have c, so we have some related phenomena. So if this is the case, we say that R1 now square on left hand side, radius of the cycle square, will be equal to F1 square plus G1 square minus C1. Also, radius of the second cycle will be equal to F2 square plus G2 square and then minus what? C2. So this is equation 5 and this is equation 6. So if that's the case, you say that this will be go for the 8th step. 8th step, we say that substitute equation 5 and the equation 6 into equation 4. So if you substitute, and hence when you write on this side, I believe that you're enjoying the beauty of basically engineering and scientific mathematics. Okay. So you say that for this side, we'll have what F1 square plus G1 square minus C1. Okay. then plus what? So we have F2. So I'm replacing R1 with the value of R1, and R2 is the value of R2. F2 plus G2 minus C2, right? And then we say that this will be equal to what? These expressions of right hand side. And on the right hand side, we have F1 square plus F2 square F2 square minus 2 F1 F2 plus G1 square plus G2 square, then minus 2 G1 G2. So we can simplify. Here we have F1 square, F1 square. Then here we have F2 square, plus even this one is F square and F2 square. So here we have G2 square, G2 square, G1 square, G1 square. So on left hand side we have negative center 1 minus center 2. This is equal to what? Is equal to negative twice F1 F2 minus 2 G1 G2. Divide by negative sign on both terms of left hand side and right hand side. So center 1 plus center 2 now is equal to 2 F1 F2 plus 2 G1 G2. So now this is the condition for the two cycles to intersect orthogonal. So this is the formula that we will be using on solving problems. Right? So the formula, so we say that the condition for the two cycles to intersect orthogonally is given as what? Center 1 plus center 2 is equal to twice F1 F2 plus twice G1 G2. And this is under condition that C1 and C2 are centers of cycle. Centers of cycles. Then F1 and F2. F1, G1 and F2, G2. Those are the coordinates of the center. So if that condition is obeyed, then we say that the two cycles have intersected orthogonally. And do you enjoy the beauty of basic engineering and scientific mathematics? Tell me in the comment sections. Possibly that maybe you say that this is stuff too difficult. They're not too difficult. They are very interesting, that they are very simple. If just you revise these revisions twice in a day, after a week, within a week, then everything is in your mind. For instance, myself, I was not checking from the book. I was not just copy and pasting from the exercise book. This information has been written in my mind. So to you, it might be done even greater than to my side. So we have, let me teach you now example 13. Example 13. So I'm going to teach about orthogonal cycles. And this question, we took it from Pure, the book called The Pure Mathematics by Tranter. I mentioned it in the reference books of lecture 00, the demo introductions of basic and scientific mathematics for ordinary diploma. And this is page G. Took this question from page 316, and it was question number 21. Then the question state and show that the cycles x squared plus y squared plus 4x minus 2y minus 11 is equal to 0. And the x squared plus y squared minus 4x, hence we say that minus 8y minus 11, this is equal to 0. Intersect at right angle. So this intersect at right angles. So you have to show that the two cycles which have been given there, they do intersect at right angles. See that how we can verify. Okay, are you ready? Have you finished the copy? You can pause the video and then, because you know every piece of information which are useful in this concept, right angles means that the orthogonal or perpendicular, those are the other synonyms. So you can pause the video and then you can do it yourself and enjoy the beauty of engineering and scientific mathematics, right? For the best technicians. Solution. So then the first step, if you refer the conditions here, we need to know the center of the cycle, first of all. Second, we need to know the center, means the value of C in the equation, the value of C, these are not the centers, the value of C, excuse me, let me correct. These are the value of C in this equation. Okay? So the value of C in that equation. So then we have to know the centers of each cycle. So we need following step. The first step, so the first step, we say that compare equation 1 with the standard equation of cycle. So we have here x squared plus y squared plus 2fx plus 2, this is the standard equation of the cycle. 2gy plus c is equal to 0. So if I don't compare with this one, x squared plus y squared, then you have plus 4x, and then you have minus 2y, then you have minus 11 is equal to 0. So you find that 2f is equal to 4. And also you find that 2gy is equal to 2. So the coordinates there will be 2, 1. Is it? 2, 1. Negative 2, 1. So from here, so suppose that this is equation 1, so C1 is equal to negative 11. What if we compare that is f equal to 2 and is g equal to negative 1? You have 2, negative 1. Is it 4x or is it 4x? Yeah, okay. So I was trying if we can simplify life here. 2x compared to 4x. And we get f is equal to 2. Then take this compared to this one. So you get g is equal to negative 1, but it's not true. If you could have such kind of the comparisons, you could do it quickly. That's not true. Unfortunately, the coordinates are not that. Okay. So therefore, C1 is equal to negative 11. That was main objective. So then we say that similarly we take for we have x squared plus y squared plus 2gy plus 2 fx plus c is equal to 0. Then we'll be given such x squared plus y squared, then minus 4x, but let's compare with y, minus 8y, and minus 4x, minus 4x, minus 11 is equal to 0. So let this is to be C2. So again, C2 is equal to negative 11. That's the first step. The second step, let us compute the second step. We say that let us compute the centers, okay? Centers of the circles. Okay, let us begin from that one. So we collect like terms, x squared plus 4x, then CR40 plus y squared minus 2y, y squared minus 2y minus 11 is equal to 0. Is it? Yeah. So then, by perfect 2 square, middle terms is 2 square, then minus 4 or 2 square, hence plus what? Y minus 1 square minus what? 1 square minus 11 is equal to 0. So x plus 2 square plus y minus 1 square minus 5, so minus 12 minus 16 is equal to 0. So x plus 2 square plus y minus 1 square is equal to 16. So for this case, if you compare the standard, you also get that negative 2, 1, and the radius is equal to 4. Negative 2, 1, which is quite different from this. So again, let us find out side step. So side step, let us compute. Let us compute what? Let's compute centers, center and radius. Okay, or the second equation, which you have to collect like terms, x squared minus 4x plus y squared minus 8y minus 11 is equal to 0. So then, by perfect square minus what? 4 plus what? Y minus 4 square. Then this one is minus what? So this you say that minus 4 minus 16 minus 11 is equal to 0. So x minus 2 square plus y minus 4, this is equal to what? Negative 20, negative 31, negative positive 31, right? So for this case, we find that center of the cycle, if you compare, it is 2, 4. If you compare, because we compare with x squared minus x minus a squared plus y minus b squared. So centers 2, 4. Yeah. So then we say that we go for the first step. we say that you have to recall the condition. Recall the condition. The condition say that value of C1 plus C2, this is equal to what? This is equal to the square root of what? F2 minus F1 square plus G2 minus G1 square. So then we say that, okay, so we have this side, so let us look for the left-hand side. So left-hand side, we take what is F2, so we can take this as coordinates of the second plane, coordinates of the first plane. So that will be 4 minus 1 square plus what? 2 minus 2, c plus 2 square. All right? Okay. So then we say that this makes what 3, so we make 9 plus this makes it 4 square, this one is 16, and this makes what 25. So if you find the under, answer is 5. It should be, did a mistake. Did a mistake here. Excuse me, this is wrong. We say that the value of C1 plus value of C2 is equal to what? Is equal to 2 G1, G2 plus 2 F1, F2. So suppose that this is F2, this is F1. So if we consider left hand side, first of all, or we consider this side, we have negative 11. And then we say that negative 11 negative 11 positive 11. Okay, excuse me, this is positive 11. So this is positive 11. Okay, so negative 11 plus what is positive 11? This is equal to 2. What is G1? G1 supposed is negative 2. What is G? No. G1 supposed is 1. What's G2? G2 is supposed to is 4 plus 2. What's F1? F1 supposed to is negative 2. What's F2? F2 is equal to 2. So this is equal to 0 on the left hand side. So this side we say that 2 times 8 times 4 it is 8 plus 2 times that one is equal to minus 8. Wow! So 0 is equal to 0. Hence shown. If left hand side is equal to left, is equal to the right hand side, hence shown that 2 circles intersect. So hence showing that 2 circles intersecting at right angle. So you see how this mathematics is beautiful. Have you enjoyed? Tell me in the comment section. So now, if that's the case, let me give you the homework. It's a time for homework, so that I can end this session and you enjoy it. To show that the circles, that one's and that one's. Okay, so it's a time for the homework. And these questions also I took it in Atlanta, question 4. Just now it is question 4. And this is example 14. And this is homework 5. Homework 6, excuse me. Homework 6. Make sure to do it before you meet for the possibly the last lecture, which is lecture 7 for this topic of cycle, where I will teach about problem solving or solving questions of the cycle. Show that the cycles x squared plus y squared minus 2ax plus c squared is equal to 0. And also the other question is x squared plus y squared minus 2by then minus c. And c squared is equal to 0. Orthogonal. That is. So it's a little bit tricky question, but you have to be careful. When you be solving it, you have to be very careful. And you have to understand the concepts which you've been doing together. But to make sure that it's a kind of the conceptual questions. You have to think around for things that are very simple. Everything is clean there. Okay, so this is the time, very good moment for students. This is the end of lecture 6 of intercept of the 2 cycles orthogonally. I really thank God who have been with me. I firstly thank God who have created me in His image and likeness. I thank God also who have given me a gift of teaching, and I thank God who have given me this international and national idea of teaching from one generation, from the present generation to the future generation. And I thank God who have given me opportunity to come and teach you and prepare these contents and teach you. And also right now that you have been taking them and throw them into the advanced processing equipments or multimedia equipments just to process it and then just to publish it to you. And God has been faithful. I thank you for your time that you have taken to be with me. May God bless you abundantly. And I thank you also for your prayer. Thank you for your free willing thanksgiving. It has been received and will be used effectively in order to pay for the running cost every month, running cost or every day, running cost for this program. I would like to invite you in lecture 7 when I'll be teaching you about problem solving. We'll be solving different problems now or different questions of the cycle so that you will master the contents and enjoy them for the rest of your life. And I would like to ask you to remember to subscribe onto online Diploma Polytechnic Institute of Tanzania in square bracket Olenjolaim, because we have already posted more than 30 videos right now to train ordinary diploma students, and we're gonna post it, or we're gonna add more than 500 possibly, or more than 300 video lectures just to teach you about this stuff. So enjoy the beauty of Belsky Engineering Certificate from Mathematics. Remember, all of this piece of information will be learnings,